Okay, today's task will be to update your learning log. So hopefully you still have that. Um, and hopefully you have access to being able to print some of these things. If not, you do have copies of this inside your textbook, and then you can just look at it digitally. So I'm going to try and go over the big ideas from chapter 8. Okay, so we'll take look at a few of the math notes for these things. We'll list a couple learning logs, but hopefully this will be a good overview for what you should have gotten out of chapter 8. Um, with our tomorrow, you're going to be working on the closure, and then Thursday and Friday will be your chapter 8 assessment. Okay, so here are the learning targets for this chapter. You should be able to factor a quadratic, and that will be including if there is a greatest common factor, so factoring completely. You should be able to find the x-intercepts, y-intercepts, and vertex of a quadratic that's in factored form or standard form. And additionally, you should also be able to do it with vertex form too. Okay, so all of those forms you should be able to do. You should be able to sketch a graph of a quadratic equation written in factored, standard, or vertex form. Without using a graphing calculator. You should be able to understand the properties from the equation and where those come from. You should understand that the roots of a quadratic equation are the x-intercepts. So basically, when you see roots and x-intercepts, kind of mean the same thing for where we are now. You should be able to convert from standard form and vertex forms. To convert to vertex form, you're going to be using that completing the square method that we talked about last week. And you should be able to find the equation of a quadratic from a table or graph. Okay, so solving for that, maybe the a value if it's in factored form, or the a value if it's in vertex form, or the a and b value if it's if you are hunting for standard form. Okay, so and then at the bottom are some different terms you should maybe know. So take a look at some of these things, and if there are things that you're not sure what they mean, they are all defined in the glossary of your textbook. Okay. All right, so the first item that we're going to look at is this more vocabulary for expressions. Okay, so that showed up. When you read over this, it talks about that there are some different types of forms, but that basically a quadratic expression is an expression that can be written in the form ax squared plus bx plus c, and a cannot be 0. So it must have a squared term in order to be considered quadratic. Okay, so if we look at all of these, is this in the form ax squared plus bx plus c? Yes. The a value would be 1, the b value -15, and the c value would be 26. Is this also a quadratic? Yes, it is. The a value is 16. It doesn't have to have a middle term. It could just be 0x, and then -25 is our c value. Okay, it could be out of order like this one, but still can be written in this form. So the a value -3, b value is 5, and the c value would be 12. Okay. And then it talks about in this next part, if you read over this, that an expression written in product form is said to be factored. So when you see product form and factored form, think kind of the same thing. So if you go ahead and take this form of the quadratic and write it as x minus 13 times x minus 2, these are considered to be the two factors. Okay. And then there's just a little review of some things about what a monomial it is. A monomial just has one term, binomial is 2 terms, and a trinomial has 3 terms. So throughout this chapter, we've been doing a lot of work with trinomials, quadratics that have 3 parts. Okay, so then the second big idea was this note about diagonals of a generic rectangle. Okay, remember when we were actually in class when we talked about Casey's pattern, that in any generic rectangle, the product of this diagonal is equivalent to the product of the other diagonal. So if I take a plus b times c plus d, and I take AC and BD and multiply them, I basically get ACBD. And if I multiply these, I get ADBC, okay, which ends up being the same. Okay, and that ended up being important because it helped us figure out how to factor quadratics. Okay, so we end up using that later. Okay, so then the third note is the standard form of a quadratic expression. Okay, so a quadratic expression in the form ax squared plus bx plus c is considered to be standard form. Okay, so and then here are a couple of examples of that. Okay, so that was a note that showed up in this chapter. Okay. All right, then you're also going to need to know how to factor a quadratic expression. Okay, so basically the strategy for trying to factor is, and our example is 3x squared plus 10x plus 8. You should know to take the 3x squared, put it in the lower right, put the 8 in the lower left, put the 8 in the upper right. Then you're going to find the product of that diagonal, just from Casey's pattern. The product of this diagonal is 24x squared. The product of this diagonal would also have to be 24x squared, but since the sum is 10x, the sum of that diagonal would also have to be 10x. So then you're going to go ahead and put 10x here, and then you have to kind of hunt for these two sides. You need to look for two values that give you a product of 24x squared and give you a sum of 10x. Once you have that, you put them in here, and then you find the factored form. Okay, so you should know how to use the generic rectangle and the diamond to factor a quadratic for your test this week. Okay. Next, let's see. Learning log was on the zero product property, and then we watched a tad bit of a video on this from Hidden Figures, okay, where the girl goes up to the board and she is able to say, I solved that by using the zero product property. And the zero product property basically says that if you have a product of two things and that product is zero, then one of the two things has to equal zero, okay? So either A or B would have to be zero. So for example, if I have 2x minus 3 times x plus 5, and that's 0, then either 2x minus 3 has to equal 0, or x plus 5 would have to be 0. What would make this factor equal to 0? Well, x would have to be 3 halves. If I take 2 times 3 halves minus 3, that would equal 0. What would make this factor equal to 0? X would have to be negative 5. Negative 5 plus 5 is 0. Okay, so in this property helps us solve a quadratic when it's written in factored form. Okay, and for graphing in this unit, it helped us find the x-intercepts. Okay, so then we do need to take a few notes, okay? So what are some strategies for graphing quadratics? Okay, so we're going to be thinking about the different forms that we can graph from. I'm just kind of looking at my notes. Okay, so you should be able to graph from the 3 different forms, okay? So let's look at an example of factored form. So if I have factored form, okay, how do I graph it? Okay, so let's say that I've got y is equal to x minus 2 times x plus 3. Okay, now certainly you could use your graphing calculator and just pop it out for you, but what I wanted you to see in this unit is the tie-in between how the equation relates to the graph. Okay, so if it's in factored form, actually, let me make an adjustment. Let me throw a little 2 here in the front, okay? So because there could be an a value. All right, so if it's in factored form, probably the first easiest thing to graph would be the x-intercepts. Okay, and remember the x-intercepts happen when y is 0. So if I make y be 0 in my equation, okay, and try and solve this, that's where that zero product property comes into play. Okay, what are the x values that make this equal to 0? Well, in order for this factor to be 0, x would have to be 2. In order for this factor to be 0, x would have to equal negative 3. So if I'm going to make a graph, those would probably be the first 2 points that I would plot, okay? So I'm going to plot a point at 2, 0, and at negative 3, 0, my 2 x-intercepts. Okay, is that enough to make a graph? No, okay, so because I don't even know if it's going to open up or down or or what. So I need more information. All right, so the next thing that I might want to find is my line of symmetry. All right, so we've seen so far in this unit that all quadratics do have a symmetrical point, and the symmetrical point is going to happen halfway between the two x-intercepts. So since those are 5 apart from each other, halfway would actually be at negative 0.5. Okay, so I know my, if I go ahead and put in and draw the line at halfway between my x-intercepts, okay, that's going to help me, get this set up and have some symmetry, but it's also going to help me find the vertex. Okay, so then after I have my line of symmetry, I'm going to find the vertex. Okay, and I know my vertex is going to be on my line of symmetry. So to find the vertex by plugging in the x value from my line of symmetry. All right, so I'm going to go ahead and put in my negative 0.5 in for x in my equation and see what I get. Okay, so what's y going to be if I put negative 0.5 in? So 2 times negative 0.5 minus 2, negative 0.5 plus 3. So I'm just putting negative 0.5 back into my original equation. So I get y is equal to 2 times negative 2.5 times 2.5. And if I go ahead and multiply that out, I get negative 12.5. So I know my vertex is going to be at this point, negative 0.5, negative 12.5. Okay, so there's my vertex, okay, which is kind of a key point. All right, so then what other key point would I want on my graph? Probably another key point would be my y-intercept. So I'm going to find my y-intercept. Okay, my y-intercept happens when x is 0. So I'm going to go back to my equation. I'm going to replace x with 0. Okay, so I'm going to get negative 12. Okay, so I'm going to plot 0, negative 12. Okay, and then I could also plot negative 1, negative 12, just using some of that symmetry. And then I'm going to go ahead and sketch my parabola. Okay, so and that's how I graph if it's in factored form. Okay, all right, so how about if it's in standard form? Okay, so I'm going to go ahead and take another look at a quadratic written in standard form. Let's say I have y is equal to x squared plus 5x plus 6. All right, so again, I want those kind of key points. I want my y-intercept. I want my x-intercepts. I want to try and find my vertex. All right, so the easy first point to try and find would be, I'm going to find my y-intercept. Okay, so find y-intercept. And remember, our y-intercept happens when x is 0. So y is equal to 0 squared plus 5 times 0 plus 6. So I'm just going to get 6. Okay, so I'm going to plot that point first. So 0, 6. Okay, that's kind of a key point. Okay, all right, so next I want to try and find my x-intercepts. Okay, and if it's in standard form, okay, the only way that we can get the x-intercepts, well, I shouldn't say only way. So one way that we might want to try first is first to try and factor, okay? So factor, because then I can get them by using the zero product property. So I'm going to go ahead and try and factor this and see if it factors. X squared 6, 6x squared, okay, 5x. So let's see, I'm going to get 3x and 2x. Okay, so now I'm rewriting this as y is equal to x plus 3 times x plus 2, okay? So that means that if I want to find my x-intercepts, so I'm going to factor to find x-intercepts. I can now say, all right, 0 is equal to x plus 3 times x plus 2. Well, what x values would make this equal to 0? Well, x would either have to be negative 3 or negative 2. So I'm going to go to negative 2, negative 3, and plot my two x-intercepts. Okay, if it doesn't factor, then really you're probably going to have to just try and see if you can change it into vertex form, okay, if it doesn't factor. All right, so let's go ahead, because at this point you guys don't know the quadratic formula yet, okay? All right, so let's go ahead and find the vertex. Okay, and since we have our x-intercepts, our vertex is going to happen halfway in between. So I'm going to go ahead and make my line of symmetry. Okay, so what's halfway between negative 2 and negative 1? Negative 2.5. So I'm going to find my vertex by plugging in negative 2.5 in for x. And I can do it in either form. Okay, so I think I'm going to use this one. So y is equal to negative 2.5 plus 3 times negative 2.5 plus 2. So I'm going to get y is equal to negative 0.5 times 0.5. So I'm going to get y is equal to negative 0.25. Okay, so my vertex happens at negative 2.5. Ah, sorry. Yeah, no, that's right. Negative 2.5 and then negative 0.25. No, wait. Ah, goodness. I went down way too low. Yikes. Hopefully you caught that. Okay, so negative 2.5 and then just 0.5. Okay, so, and then that should be enough to make my parabola if it is in standard form. Okay, so those would be kind of my steps. All right, so how about if it's in vertex form? So, and remember I said vertex form is like epic form. Woohoo! Because you can find all the stuff pretty easily. Okay, so let's say it's in vertex form. Y is equal to 2 times x minus 3 squared minus 5. Okay, if it's in vertex form, the first thing you're going to do is you're going to find the vertex. Okay, and the way that you find the vertex when it's in vertex form is you hunt for the x value that would make this part of the expression 0. And then you find the corresponding y. So what would turn the squared part into 0? Well, x would have to be 3. If you plug 3 in, 3 minus 3 is 0. 0 squared is 0. 0 times 2 is 2. You're going to be left with negative 5. Okay? So I'm going to plug the vertex first. I'm going to go to 3, negative 5. Okay. Okay, so then I'm going to find the y-intercept. Okay, the y-intercept happens when x is 0. So I'm going to do y is equal to 2 times 0 minus 3 squared minus 5. Y is equal to 2 times negative 3 squared minus 5. Y is equal to 2 times 9 minus 5. Y is equal to 18 minus 5. I'm going to get 13. Okay, so then I'm going to plot the point 0, 13. I'm just going to kind of go up here. Okay. All right, so then next I'm going to find the x-intercept. Okay. All right, the x-intercept happens when y is 0. So I'm going to do 0 is equal to 2 times x minus 3 squared minus 5. Okay. All right, so I'm going to solve by undoing, okay? So I'm going to add 5 to both sides. So 5 is equal to 2 times x minus 3 squared. I'm going to divide both sides by 2. So I get 2.5 is equal to x minus 3 squared. I'm going to take the square root of 2.5. Okay. And that could either equal x.3, or I'm going to take the opposite of the square root of 2.5, x minus 3. So I'm going to add 3. Okay, so the square root of 2.5 is approximately, when I use my calculator, 1.6. Okay, plus my 3. So I'm going to get x is approximately 4.6. This one I'm going to add 3 to this. Okay, so I'm going to do negative 1.6 plus 3. So I get x is approximately 1.4. Okay. All right, so my roots ended up being irrational. Okay, so I'm just going to kind of get close. So I'm going to go back and plot. Let's see, 1.4 and then 4.6. Okay, and then I should have enough to make my parabola. Obviously, this is not kind of to scale. It's pretty far off. So I get 1.40 for this one, and this is my other root, 4.60. Oops. Okay, and there we go. Got it graphed. Okay, so next was the forms of a quadratic function. Okay, so which we just kind of went over. Standard form, ax squared plus bx plus c. The easiest thing to find is the y-intercept. Factored form is a plus b times b plus c with possibly an a value here. The x-intercepts are negative b0 and negative c0. And vertex form, a times x minus h squared plus k. Some mathematicians and books like to put a minus here, which is fine. So what x value would make the 0? X would have to be h, and if you make x be h, then the corresponding y would be k. Okay, so knowing those forms. Okay, so next big thing from this unit was how do we find the equations for quadratic tables and graphs? Okay, all right. So a couple different scenarios. So one that you worked on is, so if given the two x-intercepts, okay, use factored form and find the multiplier. So, all right, so let's say we've got this graph and we're told here's what the graph looks like. It goes through the point negative 1, 0, 4, 0, and one of the points is 2, 12. Okay. All right, so since I was given two x-intercepts, I'm going to use the factored form. So I'm going to say y is equal to, just like from this previous one, okay? So I'm going to think about the factored form. Some a value times x plus 1, okay, because that would give us this root, and x minus 4 to get this point right here, okay? And then now what I'm going to do is to figure out the a value, I'm going to use the point 212 to help me. So I'm going to make x be 2 and y be 12. So 12 is equal to a times 3, negative 3, negative 2, sorry. So 12 is equal to negative 6a, so my a value would have to equal negative 2. Okay, so that gives me my equation. So it would be y is equal to -2 times x plus 1, x minus 4. Okay. All right. So how about if I was given the vertex? So, yeah, I'm going to just get another sheet of paper. So second source scenario, if given the vertex, use vertex form and find the multiplier. All right, so let's say this is our scenario. Oops, sorry. Let's say I've got a parabola that looks like this. I'm told that the vertex is 3, 2, and it goes through the 0.76. Okay, so I'm going to use my vertex form. Okay, so just kind of like on this other, okay, thinking here. So this vertex form. And I'm going to start with y is equal to a times x minus 3, okay, squared plus 2. Okay. All right, now I'm going to replace my x with 7 and my y with 6. Okay. So 6 is equal to a times 4 squared plus 2, and I'm just solving for my a. 6 is equal to a times 16 plus 2. I'm going to subtract 2 from both sides. I get 4 is equal to 16a. Divide by 16. A is going to be 0.25. Okay, so then I've got y is equal to 0.25 times x minus 3 squared plus 2. Okay, so that's what I would do if it were in vertex form. Okay. All right, so here's the one that requires the most work. So if you're trying to find the equation of a quadratic and it's in, and you're given the y-intercept, you're going to have to be given 2 other points, and this is the one that requires some work. Okay, so if given the y-intercept, use standard form. Then write a system of equations. To find A and B. Okay, so I think I'm gonna use a table for this one. So let's say I've got -2, -10, 0, 4, 1, 5. Okay, so if I start with this one, I'm going to be given y is equal to ax squared plus bx. I know that my c value is 4. Okay? All right, so then what I'm going to have to do to figure out my a and b is I'm going to have to use the point -2, -10, and 1, 5, and I'm going to have to solve for a and b. Okay, I'm going to first plug this point in. So if I plug in a -2 for x and -10 for y, it's going to look like this. So I'm going to get -10 is equal to -2 squared is 4. So I'm going to write 4a minus 2b plus 4. I think I'm going to get the 4 over here. -14 is equal to 4a minus 2b. Now that's not enough information to figure out what a and b are. Okay, so I need my second equation. So now I'm going to use the 0.15. So 5 is equal to a times 1 squared plus b times 1 plus 4. 5 is equal to 1 squared is 1 times a is a. 1 times b is b plus 4. I'm going to subtract the 4. So I get 1 is equal to A plus B. Okay, so now I'm going to solve my system with these two equations. So I've got negative 14 is equal to 4A minus 2B. And I've got 1 is equal to A plus B. I think I'm going to multiply this bottom one by 2. So let's see, 2 is equal to 2A plus 2B. Okay, so this is going to give me negative 12 is equal to 6A. So A must equal to negative 2. Now that I know what A is, I'm just going to use one of my two equations to figure out what B is. I think I'll use that one. 1 is equal to A plus negative 2. So I'm going to add 2. So I get 3 is equal to A. Okay, so now I know when I go back to my original equation what my A, B, and I knew my C from originally. So my function is going to be y is equal to 3x squared. Oh, no, not 3. A value, negative 2 x squared plus 3. Oh, goodness gracious. I put in the negative 2 over here for B instead of A. Hopefully you guys caught that. Okay, so sorry again, 1 is equal to negative 2 plus B. So I'm going to add 2 to both sides. So I get 3 is equal to B. Sorry about that. And so y is equal to negative 2x plus 3 x plus 4 would be my standard form equation. Can you tell that's a negative? Okay. All right, goodness. So one last big thing that we did in this unit. There's so much stuff here. All right, what are some strategies for converting from standard form to epic vertex form? So that's what we did Thursday and Friday last week. We basically use the idea of completing the square, okay? So we're going to use completing the square. Okay, as our technique, okay? So, and then if we were in regular school, I'd probably, so we're just, for our purposes right now, we're just going to, I know there could be an A here in front, but I did not do any with this A, okay, in front. All the ones that I gave you with the tiles just had an x squared here, but this actually has to be kind of a perfect square too. If there was an A value in front, like let's say I was trying to change y is equal to 4x squared plus 10x plus, I don't know, 12, okay, into vertex form, you really need the x squared to be just alone. You shouldn't have this number here. So what you would do is you would just start by dividing everything by 4 and just holding the 4 over here. Okay, so and changing it to x squared plus 2.5x plus 3. And then you'd work with completing the square with this part, okay? I think just since we weren't in school to do that, I think I'm going to just, the ones that I give you on the test will not have an A value that you have to worry about. Okay, so I'm going to give an example that doesn't have that you have to worry about. Some of you guys might get this if you're, but I'm not going to worry about that at this point. So let me do one that the A value is just 1. Okay, so let's say I've got x squared plus 8x plus 10, and I want to try and put that in vertex form, okay? I'm going to go ahead and make my generic rectangle. This has to be a square when I'm completing the square. This has to be a square. So when I put the x squared here, I'm going to take my 8x and I'm going to split it into 4x and 4x. Okay, so you must split the bx into 2 equal parts. Then this is going to be x and 4, x and 4. What would the corner be? 4 times 4 is 16. Okay, if I were doing this with tiles, I would only have 10 here, so I'd be short 6. So I'd have to add 6 ones, and then I'd have to add negative 6, okay? So that I basically am adding 0. So I'm going to have to subtract the 6 off so that I do only have a total of 10, Okay, so in vertex form, this would be y is equal to x plus 4 squared minus 6. Okay, so let me just do one more of those so you can see that again. Let's say I had y equals x squared plus 5x minus 3. Okay, I'm going to make my generic rectangle. Okay, I'm going to put my x squared here. I'm going to split that. So 2.5x, 2.5x. So I'm going to do x, 2.5, 2.5. This is going to be 6.25. Okay, so I would have had to add 6.25 because I had -3 here. I had all red ones. And then I'd also have to add 6.25 red ones. Okay, so this would give me minus 9.25. Okay, so these two things right here need to combine to be -3. Okay, all right, otherwise it's not equivalent. So I'm going to say y is equal to x plus 2.5. 2.5 squared minus 9.25. Okay, would be this in vertex form. So if you graph both of those, like on Desmos, they should match. Okay, if you want a little bit of a challenge, see if you can figure out maybe how to do that one. Okay, from back at the beginning. Okay, bring the 4 over. You're going to try and complete the square with this, and then you actually have to bring the 4 back. Okay, multiply back through by 4, but I will not test you on that. Okay, so all of them will just have an x squared here that you can start with that. Okay, all right, so that's all your notes. Those should be all the big ideas that this whole unit was about.